Today, I'll be making a magnesium oxide sodium aggregate, which, as the name suggests, contains sodium. So in this reaction, I'm going to be reacting sodium hydroxide with magnesium to create magnesium oxide with sodium metal and hydrogen gas. So the weird part is, I'm reacting a less reactive metal to create a higher, more reactive metal. This means that the entropy is negative and the reaction should not be favorable. However, since the heat of formation for magnesium oxide is extremely high at negative 601.7 kilojoules per mole, if you actually calculate the enthalpy, it ends up being negative 351 kilojoules per reaction. And thus, the reaction is favorable. So first off, I got some Drano, which is pretty much pure sodium hydroxide, and since I needed 2 moles of it, I measured 8.3 grams. Just as a note, sodium hydroxide is very caustic, so please be careful as it can cause permanent blindness and burns on the skin. Since I did not have any weigh boats, I instead used a cover for my kitchen scale. Although I did not get exactly 8.3 grams, 8.17 grams is close enough. I then got a mortar and pestle to crush the sodium hydroxide in a powder in order to increase its surface area. Since sodium hydroxide reacts with the moisture in the air, I decided to keep it in an airtight Ziploc bag. And now onto the magnesium. Since the molar mass of magnesium is 24 grams per mole, I would need 5 grams of it for it to completely react with the sodium hydroxide. This step was a nightmare since I did not have any magnesium powder and I had to cut magnesium ribbon. Once I got my magnesium, I just poured it all into a stainless steel soup can. For the reaction, I would first get a big container and pour a lot of water into it. Because sodium is an alkali metal, I'll be using this water to test its presence in the aggregate we'll be making. I then poured all my sodium hydroxide powder in the can with magnesium ribbon in it. To start this reaction, I would first need to light it on fire. However, since sodium is being produced, I did not want it to get oxidized. So in my first run, I got some magnesium ribbon to act as a fuse, and I put a brick on the can so that oxygen won't come in. However, the magnesium ribbon wasn't able to burn into the can. So I decided to first light the magnesium and then drop the brick on top of the can. However, this method got extinguished as well. No aggregate was formed, meaning that the chemical reaction did not take place. As the last effort, I just lit the magnesium and dropped it in the can without putting the brick on top of it. Although this would lead to a lower yield because of the oxidized sodium, it actually worked. Once the fire stopped, I got the can and I dropped it inside of my water bath. Once the can was cool, I got a piece of paper and I folded it in half, and I used some pliers to grab the can and take out the aggregate. If sodium was present in this aggregate, it would violently react with the water. So although my yield was pretty low, I confirmed the presence of sodium metal in my aggregate.